In this video, I'm going to talk about how to invert a quadratic function like x squared minus 2x plus 3. At the top of the screen, I have made some notes about how to invert a function in general and how the domain and range of a function works. So if you need to, pause the video and familiarize yourself with the facts at the top there. So what we are going to want to do is take f of x, which is x squared, take 2x plus 3, and we're going to want to find the domain and range of the inverse function, and also we're going to want to find the inverse function itself once we've done that. So if you look at the graph here, we can see that because x is greater than or equal to 1, f of x is a one-to-one function. So we've used that domain specified there, giving us a one-to-one function. So it does have an inverse. The range I've calculated, which you can see on the graph, is that f of x has to be greater than or equal to 2. And using that information, we can think about part A, which is find the domain and range of the inverse function. So let's think about doing that. So we're going to want to find the domain of f inverse and the range of f inverse. And we're going to get those by thinking about the domain and range of the original function f of x. So if we think about the range of the original function, it was f of x is greater than or equal to 2. And that means the domain of the inverse function is x is greater than or equal to 2. So the range of the original function turns into the domain of the inverse function. Similar thing will happen with the range. That will be related to the original domain. So the domain of f turns into the range of f inverse. So those two things have been swapped in order to give us the domain and range of f inverse. So that's part A done. So now we want to think about moving on to actually invert it. So step 1, replace f of x with y. So we're going to take that function and we're going to write y equals instead of f of x. So y equals x squared minus 2x, add 3. And then a step that a lot of people forget, but which will make things much easier, is to complete the square on that quadratic. So x minus 1 squared, and then you've got to think we need to subtract a 1 from the minus 1 squared, but we've also got to add the 3. So when you tidy all that up, you'll get x take 1 all squared plus 2. So complete the square if you want to invert a quadratic function. Now we proceed to step 2, swap x and y. So we can just do that. So x equals brackets y take 1 squared plus 2. And that's that done. Now step 3, we want to do whatever algebra is necessary to make y the subject. So just zooming in so I can get a bit of extra space on this. So we have currently got x is y take 1 all squared add 2. We want to try and make y the subject of that equation. So I've moved the 2 over to the other side. So x take 2 is y minus 1 squared. So now I need a bit of extra space to work with. Get the view sorted out and we'll be able to carry on. So we want things nice and big. Okay, so we've currently got x take 2 is y minus 1 squared, and we're going to root both sides. When we root x minus 2, we need a plus or minus symbol, don't forget that. On the other side, you're rooting a bracket squared, so you just get y take 1. And we're pretty close to making y the subject, we just add 1 to both sides. So y is 1 plus or minus the square root of x take 2. Now we've got an issue here because we've got a plus or minus showing up, which means we don't really know what the inverse function looks like. Is it 1 plus root x minus 2, or is it 1 minus root x minus 2? It needs to be one or the other. The inverse function needs to be 1 to 1, so it has to have one y value for every x value. So we have now run into a problem which we're going to solve by referring back to the properties we want our inverse function to have. So keep that in mind and look back at the domain and range that we wanted f inverse to have. And we want to make sure that those line up. So thinking about the domain, we want that to be x is greater than or equal to 2, which fits because if you look at the square root part, it makes sense that x would have to be bigger than or equal to 2. The range tells a different story though, so let's copy that range down so that we can compare it. We want the range f inverse of x is greater than or equal to 1. So our inverse function needs to have that as its range. Now if we look at y, we need to make a choice that will give us that range. So that tells us that y must be 1 plus the square root of x minus 2, because then all the y values will be bigger than or equal to 1, which means it will have the range that we know the inverse function is meant to have. So we reject the answer that's got a negative in it, because that would have the wrong range. It wouldn't match up to what we know from earlier in the question. We've made y the subject. We now just need to write our answer in the correct form, which doesn't have a y. It should have the symbol f inverse of x. So I've made a mistake there, started with a y. That's exactly what I don't want to do. I want to replace the y with f inverse of x. And that's our inverse function. That's the correct one, and it has the domain and range that we found out earlier on. That will all fit together and make sense. X has to be bigger than or equal to 2 for the square root to work out, and the range, we're adding something on to 1 every time that's positive, so f inverse will be greater than 1. So that is our overall solution. You can look at everything we've done there, and it's really important to think about how we dealt with that issue of a plus or minus. So we ended up with a plus or minus. We needed to figure out which one was correct, and we did that by making reference to the range that the inverse function was meant to have. So it was meant to have the range that we worked out right back at the start. And in order for it to have that range, in this question, we knew that the plus or minus had to actually be a plus. Thank you very much for watching.